Hello, this video is on section 2.4, which is titled Deductive Reasoning, and the learning target for this video is to use law of detachment and law of syllogism. There are two laws that we're going to be going over into a little bit of detail using some examples. But before we do get into those two laws, there is one definition I want you to copy down. The first one is deductive reasoning, which is the title of the section. And deductive reasoning is a process of reasoning logically from given statements or facts to a conclusion. So if you have maybe a conditional statement that is an if-then, you look at your hypothesis, you reason logically to come to a true conclusion. Or maybe you start out with a false hypothesis to come to a false conclusion. Okay, so the first law is law of detachment. And the law of detachment is if the hypothesis of a true conditional statement is true, then the conclusion is true. So if we have a conditional statement, P then Q, if P is the one true, that must mean Q is true. And these three dots right here that I have in a little triangle, this symbol means therefore. Okay, so if P then Q, P is true, that means Q, therefore, must be true. You cannot have a true hypothesis in a conditional statement that is true and have a false conclusion. Both of them must be true. Let's take a look at an example. If a student gets an A on a final exam, then the student will pass the course. This is a conditional statement, and this is a true conditional statement. Now, we do have this other expression or statement right here that is Felicia got an A on her exam. So if the hypothesis is if a student gets an A on the final exam, that must mean that the conclusion is then the student will pass the course. So we have a true hypothesis and a true conclusion. If Felicia gets an A on her exam, Felicia is a student in the class, so if Felicia gets an A on her final exam, therefore, Felicia will pass the course. I'm using deductive reasoning by taking my statement and basically replacing my hypothesis with it, and instead of student, it is Felicia. Felicia got an A on her exam. Therefore, she has to pass the class. Same exact thing with this example down here. If there is lightning, then it is not safe to be out in the open. If there is lightning is my hypothesis, it is the statement following the if, and my conclusion is the statement following the then. Then it is not safe to be in the open. So if you are outside in the open, then it is not safe to be in the lightning. That would be the converse. But right now, we have a hypothesis of if there is lightning. The conclusion is then it is not safe to be out in the open. So we have a statement that is Marla sees lightning from the soccer field. So Marla sees lightning, and she is in a soccer field, which is out in the open. So therefore, Marla is not safe in the open. Okay, again, replacing this statement with my hypothesis, since she sees lightning and there is lightning, therefore I can conclude, based on my conditional statement, that it is not safe to be out in the open. This is using the law of detachment. If P then Q, P is true, therefore P must be Q. Okay, and the other law that we've talked about, or that I want to introduce, is the law of syllogism. Syllogism. And the law of syllogism tells us if we have a conditional statement where P then Q is true, then we have another conditional statement where Q then R is true, we can therefore conclude that P then R is true. So you have a hypothesis to conclusion in one statement. Then you have another conditional statement where the conclusion of the first one is now your hypothesis of the next one, and you have a new conclusion is also true. That must mean the hypothesis of your original conditional statement and your conclusion of your second statement is true. Let's take a look at an example. If a figure is a square, then it is a rectangle. This is my hypothesis. If a figure is a square, my conclusion is then it is a rectangle. Okay, easy enough. After the if is my hypothesis, after the then is my conclusion. Taking a look at the second one, if a figure is a rectangle, is my hypothesis of this one. Then it has 4 sides is my conclusion of this one. So since my conclusion of my first statement is it is a rectangle, and my hypothesis of the second one is it is a rectangle, both of these concluding statements are true. Therefore, I can say that if a figure is a square, then it has 4 sides. Since each of my conditional statements are true, I can say that the hypothesis of my first and my conclusion of my last is true in an if-then conditional statement, since these two match up word for word. One last example. If you do gymnastics, then you are flexible, is the first conditional statement. It is an if-then. Hypothesis is if you do gymnastics. The conclusion is then you are flexible. Taking a look at the second one, if you do ballet is the hypothesis of my first or second conditional statement, and then my conclusion is then you are flexible. It's an if-then statement. Okay? Since my conclusions are the ones that match up, and my conclusion does not match up with my hypothesis in either of the concluding statements, I cannot conclude anything based on these statements or using deductive reasoning or using the law of syllogism. There is no P then Q, Q then R. It is P then Q, R then Q. There's nothing I can conclude. I could say if you do dance, then you are flexible. If you do yoga, then you're flexible. There are a whole bunch of other things that you could do that would make you flexible. But in no way can we conclude that gymnastics and ballet both make you flexible. So there is no conclusion. We cannot make any connections between the hypothesis and conclusion of either of these statements. Okay? Thank you.